Hello guys. In this video, we're going to talk about how to take the derivative of log-based functions. So basically, if you have a function that has a logarithm, not a natural log, a logarithm of base a normally is 10 on most logarithms, then the base logarithm is 10, but if you can just identify it as a, you'll be more adaptable to when you don't see 10 as your logarithm. And then u is just the function of the logarithm. So without further ado, we have a problem right here. Fx is equal to log of base 10 of x squared. So the first thing we need to do to simplify this problem is we want to be able to identify the variables that are over here, because this is our formula to take the derivative. So we want to be able to identify u prime, and a. We want to be able to do this very easily, because if you identify the variables, it's literally just a matter of plugging them in. So without further ado, our a is our base of the function. So our a in this case will be 10. Our u is whatever you see inside the parentheses right here. So whatever you see inside the parentheses. So in this case, it is x squared. This would be our u, x squared. And taking the derivative of that, our u prime would just be equal to 2x. So now it's just literally a matter of just plugging these in. So now we identified a, u, and u prime. A is our base, and then u is whatever is inside the logarithm. Whatever function is inside the logarithm, that is your u. Your a will always be your base. So your a is your base, and your u is the function inside the log. So function inside log. That's how you identify a and u. Then the third step is just literally plugging in. So plug into the formula, and then the formula, of course, is pretty straightforward. So the formula is u prime divided by u times the natural log of a. So in this case, our u prime is 2x divided by our u is x squared times the natural log of a. So this would be the natural log of 10, because our a, we identified it to be 10. So this right here is our final answer. And this is how we take log-based derivatives. So step 1, if you see a logarithmic function, know that this is the formula. So this is step 1, and be able to identify the formula. Step 2, identify the variables that you're going to use in your differentiation. So identify your a as your base, your u as your function of the inside the log, and your u prime as a derivative of u, because later on in step 3, you're literally just going to plug them into the formula. And that's how you take log-based derivatives. I hope this was helpful. Thank you guys for watching. If you need any help with other calculus, it's all in this playlist. Thank you. Hello guys. In this video, we're going to take log-based derivatives. So what does that mean? That basically just means that we're going to take derivatives of log functions. So normally logarithmic functions do have a base of 10, but I denote this as a because a can mean any number. So you want to be adaptable to whatever number is your base. Don't just get accustomed to being 10. So right here, we have y equals log 5 of x raised to cube power n. I probably could have made this a better y, but yeah, this is all equal to y. So what we're going to do is we need to recognize the form of this as log of base a to u. So our a is our base right here, and our u is the function. Whatever function is inside the logarithm, that is your u. So right here, we are going to identify variables a, u, and u prime. So what is the base of this function? The base of this function is, what is the base? It would be 5. What is our u? What is the function inside the logarithm? Our u is whatever is right here inside the parentheses. So in this case, our u is going to end up being x cubed. And our du, our u prime, is taking the derivative of u. So this would just simply be 3x squared. So now that we have this, we're going to take this a step further, and we're going to go ahead and now we're going to differentiate. Now we're going to find the derivative. So all we have to do to find the derivative is literally just plug in these variables that we identified to be a, u, and u prime, and literally just plug them into the formula. It's that straightforward. So what is our formula? Our formula is up here. Log base a of function u prime is equal to u prime divided by u times the natural log of a. So without further ado, we plug in these variables. So u prime's right here. So 3x squared divided by u is x cubed. Cubed times, that's a cube. You understand that as a cube. Times the natural log of 5. And that's the base of our function. So this is how you take natural log. This is how you take log-based derivatives, not natural log. Natural log is something completely different. When you see natural log, you apply something different, which is on this playlist. I have a video for natural log derivatives. Log-based derivatives is if you see a log function of base a of a function u. So remember, a is the base, u is the function. So step 1 is recognize the form of the log. Step 2 is identify your variables a, u, and u prime. Know that a is your base, u is your function. And step 3, literally just plug and chug. Plug in them into the formula. Knowing this formula right here is also very critical into solving this problem. So plug in u prime, plug in u, and plug in the natural log of 5. Most of calculus is just identifying variables and plugging them into a formula. So for this log-based derivative, identify the variables of the function, or first recognize the function as a log base, then identify the variables a, u, and u prime, and then plug them into the formula to get this answer. All right, I hope that was helpful. Thank you guys for watching. If you see any value, y'all know what to do. Bye.